Hello, knowledge seekers. Welcome to Eklavya Gyan. Today, we are going to talk about Brahmagupta. Brahmagupta, the great 7th century Indian mathematician and astronomer, wrote some important work on both mathematics and astronomy. He was from the state of Rajasthan of northwest India. He is often referred to as Bhilammacharya, the teacher from Bhilammala, and later became the head of the astronomical observatory at Ujjaini in central India. Most of his works are composed in elliptical verses, a common practice in Indian mathematics at the time, and consequently have something of a poetic ring to them. It seems likely that Brahmagupta's works, especially his most famous text, the Brahma Sapta Siddhanta, were brought by the 8th century Abbasid Caliph Al-Mansur to his newly founded center of learning at Baghdad on the banks of the Tigris, providing an important link between Indian mathematics and astronomy and the nascent upsurge in science and mathematics in the Islamic world. In his work on arithmetic, Brahmagupta explained how to find the cube and cube roots of an integer and gave rules of facilitating the computation of squares and square roots. He also gave rules for dealing with 5 types of combinations of fractions. He gave the sum of the squares of the first natural numbers as n into n plus 1 into 2n plus 1 by 6, and the sum of the cubes of the first n natural numbers as n into n plus 1 by 2's whole square. Brahma Sapta Siddhant treats 0 as a number. Brahmagupta's genius, though, came in his treatment of the concept of the new number 0. Although often also attributed to the 7th century Indian mathematician Bhaskara I, his Brahma Sapta Siddhanta is probably the earliest known text to treat 0 as a number in its own right, rather than as simply a placeholder digit as was done by the Babylonians, or as a symbol for a lack of quantity as was done by the Greeks and Romans. Brahmagupta established the basic mathematical rules for dealing with 0, which was 1 plus 0 is 1, 1 minus 0 is equal to 1, and 1 multiplied by 0 is equal to 0, although his understanding of division by 0 was incomplete. He thought that 1 divided by 0 is 0. Almost 500 years later, in the 12th century, another Indian mathematician, Bhaskara II, showed that the answer should be infinite, not 0, on the grounds that 1 can be divided into an infinite number of pieces of size 0. An answer that was considered correct for centuries. However, this logic does not explain why 2 divided by 0 and 7 divided by 0, etc. should also be 0. The modern view is that a number divided by 0 is actually undefined, that is, it does not make sense. Brahmagupta's view of numbers as abstract entities rather than just for counting and measuring allowed him to make yet another huge conceptual leap, which would have profound consequences for future mathematicians. Previously, the sum 3 minus 4, for example, was considered to be either meaningless or at best just 0. Brahmagupta, however, realized that there could be such a thing as a negative number, which he referred to as debt, as opposed to property. He expounded on the rules for dealing with negative numbers. For example, a negative times a negative is a positive, and a negative times a positive is a negative. Furthermore, he pointed out quadratic equations for the type x square plus 2 is equal to 11 could in theory have 2 possible solutions, one of which could be negative because 3 square is equal to 9 and minus 3 square is also equal to 9. In addition to his works on solutions to general linear equations and quadratic equations, Brahmagupta went yet further by considering systems of simultaneous equations and solving quadratic equations with 2 unknowns, something which was not even considered in the West until 1,000 years later, when Fermat was considering similar problem in 1657. Brahmagupta's theorem on cyclic quadrilaterals. Brahmagupta even attempted to write down these rather abstract concepts using the initials of the names of colors to represent unknowns in his equations, one of the earliest imitations of what we know now as algebra. Brahmagupta dedicated a substantial portion of his work to geometry and trigonometry, He established root under 10 is equal to 3.162277 as a good practical approximation for pi, which is 3.141593, and gave a formula now known as Brahmagupta's formula for the area of a cyclic quadrilateral, as well as a celebrated theorem on the diagonals of a cyclic quadrilateral, usually referred to as Brahmagupta's theorem. Thanks for watching. If you liked the video, please give us a thumbs up, subscribe our channel and share it with your friends.